Okay, welcome America, welcome Justin Bieber. Today we are reviewing for our exponential and logarithms first test. So I'm going to do two problems for you today on a worksheet that I will attach. We are going to graph problem number five, which is an exponential function. And then I'm going to take you to problem number 14 and we're going to solve a logarithmic equation, or maybe it's an exponential equation. I can't remember. We'll find out. Okay, so we're going to start with our 2 points. So our 2 points are 0, 1, and 1, 3. And just to review, the parent function for this equation, that is too loud, is y equals 3 to the x. So if I plug in 0 for x, 3 to the 0 is 1. And that's where that point comes from. So here's the parent function up here. Y equals 3 to the x, right? So if I make an xy chart and I plug in 0 for x, I'm going to get 1 for y. And if I plug in 1 for x, I'm going to get 3 for y. So we always use 0, 1, and then 1, and then the base. You don't need to go through all that, but that's where these points come from. So I'm going to go ahead and plot those, and then I'm going to move them left 4 and down 2. Using the transformation properties that we learned from Unit 1 and also Algebra 2, I believe. So there's 0, 1, and 1, 3. And I'm going to move them in a different color. I'm going to move them left 4, and down 2. So 1, down 2, right there, and then left 1, 2. Good enough. The other thing I need to do is graph the asymptote. The original parent function asymptote is at y equals 0. And that's because if you think about what y values, if I made this xy chart for the parent function, what y values could we have here? If I put in anything higher than 1, 2, 3, 4, 5, we're going to get positive y values. Okay. If I put in a -1, I'm still going to get 1/3. If I put in -2, I'm going to get 1/3 squared. I'm never going to hit 0. So we don't have any y values below the x-axis. So that's where the original asymptote is. However, this one has been moved down 2. So I'm going to go ahead and draw that in. And now we graph. We only need those 2 points. We've plotted them, we've shifted them, and now we've got the asymptote. So we're just gonna, and the graph has to be approaching the asymptote, and it looks like it's exponentially going to continue up. Good enough. Okay, domain and range, and this is going to be tested next class. The domain are all the possible x values in this xy chart for this function, not the parent function. So what are all the, if I look at every single point on this graph, okay, in every direction, what are the possible x values? That's the domain. This arrow is continuing left forever. This arrow is going up, but it's still continuing right forever. So that is from -infinity to positive infinity. That's all real numbers, and we are going to write that in interval notation from -infinity to positive infinity. Then for the range are all the possible y values in this graph. The y values do not go below -2, so they don't include -2. So all the y values are above -2, but not including -2 because there's an asymptote there, so there's no graph there. So it's going to go from -2 to infinity. And the way we show we don't include -2 is we put a parenthesis next to it. Is this coming back? I had one kind of, and then everyone else, no comment. Good times. All right. So the asymptote is at y, and make sure you put y equals, because if you just put -2, what is that? Is it an x equals? Is it a y equals? This is a horizontal line, so it's a y equals -2. And this graph, is it converging or diverging? This, yes. Because it is, as x is increasing, the y values are also increasing. They're not approaching the asymptote. It's going away from the asymptote. So it is diverging from the asymptote. And that's it for number 5. How are we doing?
Not horrible.
Not horrible. I'll take it. Anyone want to show off their PJ outfits? Today's PJ day. You guys are tired today.
PJ day comes with it. Slow. I don't know why. I really don't. And I left it yesterday.
All right. Where is 14? Here we go. 14. So this is the other problem I handpicked. I'll wait till you guys get to number 14. But it's telling us to solve the following equations by rewriting the bases. So for problem number 14, we have 5 to an exponent, and then equals 1/5. If we can write 1/5 with a base of 5, then we can set the exponents equal to each other. And 1/5 can be written as 5 to the -1. So if I just rewrite that, so this is 5 to the 1 minus 2x equals 5 to the -1. Now I can just set those exponents equal to each other. And then we have an algebra 1 equation to solve. So if I subtract 1 from both sides, I get -2x equals -2. And then I divide by -2, I get x equals 1. Boom. Questions?
That one did not make sense.
What did not make sense about it?
Just the prop. Can you do it again?
Sure.
Not like that one, but a different one.
You want to do another one?
little bit.
This video is only 7 minutes long, so
I just don't really get the
pretty
steps
short.
to it.
So did you divide by 5?
You mean the first step?
Yeah, how did the 5?
No, you're talking about this step. Okay, so think about it like this, okay? If you had 3 squared equals 3 to the x, okay, we know that x is a 2. We can just set this 2 equal to x because we know that they're the same. So that's what I did here. I said, well, I don't know what this x is, but I know that this exponent is equal to this exponent. So I just set the exponents equal to each other and solved.
So we don't need the 5 at all?
No, just like over here. If this is 3 squared equals 3 to the x, we know that x is a 2 because 2 equals x. It's pretty simple when you look at it like this way, you know that's a 2, but this is why. This is why you can do that. Okay, let's do, did we do 17 last time? Do you have 17 down on your paper?
Yeah.
Okay. What about 15? Do you have 15?
Yeah.
Yeah, we did that.
We did 15? Oh my gosh, I'm so amazing. We could do 16, but I don't want it to make it, no, I'm not a fan of 16. Did we do 18? 18 it is.
Oh God, it's helping.
Why?
It's fine.
Is
Okay,
that gonna be
everything's fine. Look, these,
I don't know.
it's just an E, don't freak out, E's a number. Okay, so this is a number to an exponent in parentheses, so times a number to an exponent. What do you do when you have, and I'll write this over here, let's say we had, I don't know, 3 to the x times, and this is just from Algebra 1, these are exponent properties, 3 to the, let me see if I make this up, 3 to the, I don't know, square or something like that, okay? What this means is 3 to the x times 3 squared, right? And we know if we have numbers, how do I explain this? x squared times x to the fourth. We have the same base. We can add the exponents because what that means is x times x times x times x times x times x. So rather than go through all this, we just say this equals x to the 2 plus 4, which is x to the 6th power, which is why when you have the same bases and you're multiplying, you can add the exponents. So we have same bases here, and we're multiplying, so we can add the exponents. So I'm going to rewrite this one as e to the x squared equals e to the 3x minus 2. And now, just like the previous problem, we can set the exponents equal to each other. So that's x squared equals 3x minus 2. Now, the rest of this is algebra 2, algebra 1 and algebra 2. If I'm trying to solve this, I'm going to take everything, throw it to one side, set it equal to 0, and try to factor it. If we can't factor it, then what do we have to do? I heard a, oh God. Quadratic formula.
Oh no.
I don't know if we have to do that or not. We're about to find out. X squared minus 3x plus 2, right? Equals 0. We always try to factor first. No. Please let it factor. This is going to be x minus, so 2, 1. Oh, that works. So x equals 2. X equals 1. If you guys want to do a QF problem, we could do 16.
No,
16 ends up not factoring, which you have to do.
Yeah, no, it's
Can you write the formula? The quadratic formula?
Yeah, negative b plus or minus the square root of b times b. Hold on, let me write this as I'm writing. Negative. Okay, do y'all like my voice?
Mm-hmm.
Negative b plus or minus the square root of b times b minus 4ac all over 2a. We're going to sing it in rounds and record it and send it to the, who's the chorus teacher now?
Missy.
She's going to love it.
Yeah, she will.
Wait, the
It's
other
going to
one?
be amazing. They're going to ask me to do a cameo in the next Pride Productions program. All right, that's it for our video.